You ever wonder how your email provider just knows what's junk? Or how a website can recommend the exact product you were just thinking about? Well, it all comes down to making predictions from data. And today, we're going to unlock one of the most fundamental tools for doing exactly that.
I mean, just think about your inbox. Every single email that comes in has to face this simple binary question. Is this important or is it spam? It's a straight up yes or no decision.
Or, hey, think about it from a business's point of view. They're looking at a customer's activity online, and the million-dollar question is, are they going to click buy? It's another one of those crucial yes or no outcomes. These are precisely the kinds of problems we're going to tackle.
Okay, so here's the game plan. We're going to start in a simple world of two choices, then get into the art of probability and see how the line gets drawn. After that, we'll push beyond just a yes or no and find a solution for multiple categories. Let's do it.
So first up is our foundational tool, the one designed specifically for these two-choice scenarios. It's called binary logistic regression.
Now, here's the thing. At its heart, logistic regression isn't really about giving a definite yes or no. Instead, it's a statistical method that's all about modeling the probability of a specific outcome. It's all about figuring out the odds.
And this is really the key takeaway here. The goal is always to predict one of two outcomes. But the output isn't just a label, it's a probability, a number between 0 and 1 that tells us how confident the model is. You know, is there a 98% chance this email is spam, or is it more like a coin flip at 51%? That number is everything.
So how does it actually calculate that probability? Well, that's where we meet the mathematical engine that really powers this whole process. The secret sauce, the absolute core component that makes all of this work, is this beautiful little piece of math called the sigmoid function.
The best way to think of the sigmoid function is as a probability squasher. It's such a cool idea. It can take any number you throw at it, a huge positive number, a big negative number, anything, and it just elegantly squishes it down into that neat 0 to 1 probability range that we need. Okay, so we have a probability, a 75% chance of spam, a 30% chance someone's going to buy something. But how does the model actually make the final call? How does it draw the line between a yes and a no?
Well, it actually learns to draw a line in the data. We call it a decision boundary. On one side of this line, you've got all the yeses, and on the other, all the nos. Then it uses a super simple threshold. Typically, if the probability is over 0.5, it calls it a yes. If it's under, it's a no. Simple as that. Now, you might hear this super fancy term, maximum likelihood estimation, or MLE, and think it's incredibly complicated. But honestly, it's just a formal way of saying the model tries out tons of different lines to find the one perfect spot to draw that line, the one that gives the most accurate predictions for the data it's already seen.
So, this is all great for those simple yes or no questions. But the real world is often way more complicated, isn't it? What happens when a problem has more than just two possible answers?
Right. This is where we need to level up. We're moving beyond a simple yes or no and stepping into a world that's full of multiple categories, and that means we're going to need a new tool for our toolkit. For instance, classifying a news article isn't a yes or no problem, right? It could be sports, politics, or tech, or analyzing customer feedback. That could be positive, neutral, or negative. And trying to recognize a handwritten digit, you've got 10 options there, from 0 to 9. A simple binary tool just isn't going to cut it. So allow me to introduce the power tool for this kind of job. It's a natural extension of what we've just learned, and it's called multinomial logistic regression. This table just lays out the upgrade perfectly. So, while binary regression handles two classes with the sigmoid function to give us one probability, multinomial regression handles 3 or more classes. And it uses a new core function called softmax to give us a separate probability for every single class. And you can really see the difference here. On the left, that's our old friend, the sigmoid function, for those simple two-way choices. But on the right is its big brother, the softmax function. Just think of it as a category sorter. It looks at all the possible options at the same time and assigns a probability to each one, making sure they all add up to a perfect 100%. And believe me, this tool is everywhere. It's the tech that powers handwritten digit recognition when you mail a letter. It's behind the sentiment analysis that tells companies if product reviews are positive or negative. And this is so important, it's often the final decision-making layer in so many of the complex neural networks and AI systems that we use every single day. So think about that for a second.
If this concept of a category sorter, this powerful sorting hat, is the final step in so many AI systems, making that ultimate decision, where else in our digital lives do you think it might be quietly at work, making choices for us right now?